So next we'll go ahead with Diptangshu's session on the GUI part of OpenFOAM. So FOSSEE IT Bombay has been developing GUI since a couple of years and Diptangshu along with his team has developed some modules to solve some of the problems of OpenFOAM. So it's a very unique presentation from FOSSEE IT Bombay. I hope you all will learn a lot and you will actually start learning how to use GUI to to use OpenFlow. So over to you, Diptangshu. You can start your session.
Thank you, ma'am. So, hello everyone. I'm Diptangshu, and I'm currently working as a research assistant at FOSSEE IIT Bombay. So, I'll give a quick demonstration about the GUI for OpenFOAM that we've been working for. So, let me just share my screen first. Okay. So, currently our GUI is developed as a Blender add-on. So, if you are not aware, Blender is an open source software that is mainly used for 3D graphics and for creating 3D art and 3D animations, and also for visual effects. So it has a very nice Python API that can be used to make add-ons on top of Blender software itself, so that Blender's features can be reused for other fields. So in our case, we have made an add-on to ease the process of case building inside OpenFOAM. So currently we have a UI for block mesh for block mesh that helps us to create block mesh direct files in a easier manner. So I will give a quick demonstration here by making a Venturi tube case. So usually what we do is we write out the one block mesh direct files by ourselves by hand, or maybe we use some third-party tools to convert them into to generate block mesh direct files. So here we can just generate the block mesh files inside of Blender, and it is really helpful for newcomers if they want to understand how block mesh works. So I will just demonstrate how it is helpful. So this is the initial screen of Venturial. So it is available in the right hand side tab uh, in the 3D viewport. So here I can just select which my case directory. So I will open a temporary directory that I have here, and I'll click on OK. So this is the directory where my output dictionary will be stored. So moving on to the next tab, which is geometry. So here we will generate which blocks we need. So since I'm making a simple Venturi tube, I will need 3 hexahedral blocks. So hexahedral is the default type of blocks that I need here. Hexahedron is basically cubes. And I can set the number of cells that I need. So let's say I will take 20 cells in each direction. And I will generate my blocks. So here you can see I have 3 blocks that have been generated. And then once these blocks have been added to the viewport, I can modify their shapes however I like. So to make a Venturi tube, what I will do is I will just expand these to double this size, and let's drag it a bit backward. Okay. So this can be my inlet over here. And in this block, I will drag it, let's say 3 times, or maybe 2.5. And let's drag it outwards. Sorry. Here. So here we have a shape of a basic Venturi tube. So now that our basic shape is ready, we will select all the blocks that we have, and we can compose them to make a single mesh that is going to be our final mesh structure. Now we can modify upon this mesh as we like. So let's start by adding all the data present in this mesh into our internal software. So we will first do get blocks. So here you can see all the block data is similar to the one that you see in your block mesh file. So here you have the type of the block that you have, and you have the vertex ordering of your block, and then you have the grading, which is simple grading for now, in future, this will be changed so that you can have edge grading as well. And you will be able to change the grading scale in your in over here in the future. And next up, we will list down all the vertices that we have in here. So as you can see, I have just at a single press of a button, all the vertices are then gathered around here. So the work of this tab is done here. We'll move on to the next tab, which is edges. So the edges tab is used to generate curves in your mesh. So for example, if this were a pipe, I would have to generate some curves along the edges to represent that, okay, this edge is a curved edge. But since it is a simple Venturi tube, it is not needed. So moving on, which is boundary. So here we can mention the boundary conditions for our mesh. So for example, this was our inlet. So I can click on new boundary and I can just mention that, okay, this phase is my inlet and I want it to be of a patch type. And once I enter OK, you can see that this edge has been recorded over here. I can do the same with our outlet. This will be our outlet, and it is a patch. And enter. And I will select rest of the faces. Just a moment. Okay. So all the surrounding faces are selected. And then I can just add new boundary and I will just name it wall. And it is also a type wall. Or maybe I can just name it pipe. That will be better. It's better to have different names than the boundary type. So once I click OK, so you can see all the boundary types has been registered over here. So then I can safely exit out of edit mode. And then in the visualize tab, you can visualize all the features that you want. So let's say I want to check the vertex coordinates if they are right or not. So I can just click on this tick mark over here. And then that will enable the vertex indexing. And then I can also see vertex coordinates over here for each of the vertex. And then I can also see the boundaries that have been assigned over here. So currently these are showing only the colors, and then I have to match the colors over here with the boundary type, which vertices the boundaries are having, and what is the name of the boundary. So with that said, this mesh is now ready to be exported. So if I just generate block mesh dict over here, this in the run tab, you can see block mesh is generated in the bottom here. So yeah, in our directory, this is the generated block mesh dict file. So as you can see, it is generated by Venturial and all our data is here. So this file can be used inside of OpenFOAM. So I will just copy this and I will paste it in a sample file that I have ready. So yeah, I will replace this and let's open up OpenFOAM and then I will just show it in ParaView how the file looks like. Okay. So I have started up OpenFOAM. Let's go to the directory that I had. And in here, I will run block mesh. So the block mesh tool runs, and then I will visualize using ParaView. Okay, and apply. And here you can see the Venturi tube that I have made. So if you are wondering why it is vertical, when in Blender it was horizontal. So it is because in Blender, the axis orientation is different than that of ParaView. So in Blender, y-axis is horizontal, the x and y plane is horizontal. While in ParaView, you can see that the x and y plane are vertical. So along the vertical is the y-axis. And I can also enable the edge lines. So that shows you that all the cells are also rendered here. So this is how you can use the GUI to quickly make block mesh dict files. And it is also easy for beginners. It also makes it easier for beginners to understand each aspect of block mesh dict what each aspect does and how it matters, how it affects. And currently, development is going on for a GUI for Snappy Hex Mesh, and we will also shortly start our development and do a release for the solution modeling GUI. So this is the current state of the GUI for OpenFOAM. And if anybody has any questions, they are welcome to ask in the chat box.
There's one question that says how to use Fluent Mesh in OpenFOAM. Quickly I'll just show that. There is one command. I'm typing it in the chat for everyone to see. You can use the command Fluent 3D Mesh to foam, and then you type in whatever mesh file you've created, .msh file. So in this one, I'll type here file name .msh. So what you'll have to do is when you create your mesh in ANSYS, you will have to export it in the .msh format. Also, you have to make sure that in ANSYS you've enabled the write, whatever this you're writing it in, that msh file, that it is written in ASCII format. So in your settings, you'll have to go and enable that first. After that, we'll have to export that mesh file, the .msh file. So the command, basically you copy that msh file within your run directory or the case that you're running. So in our case, if you had the cavity case, you would put it inside your cavity case with your zero constant system. And then you'd have your .msh file also over there. So then you open your terminal, and instead of doing block mesh, now you will do Fluent 3D Mesh to foam. You will put your file name, whatever file name was of your that msh file, you put that file name .msh and you press enter. That will convert your Fluent Mesh file into a file that is readable by OpenFOAM. And then after that, you can go ahead with all the remaining solver commands that you have, icofoam, simplefoam, whichever one you want to run.
Sir, how does this OpenFOAM handle the dynamic mesh?
So for dynamic mesh, there are tutorials already readily available. So now Professor Chandan Bose will come. He will demonstrate how to basically do all the dynamic meshing and all that. So he will explain all that. Okay.
Thank you, sir. Thank you, sir.
Yes.
Also, on another note, if anybody wants to use the GUI for OpenFOAM, I have pasted the link to the release in the chat box. So you're welcome to use it and test it out. And your input will be, we need input from you guys on how you like the GUI and what other changes or what other features you would like on the GUI itself. And if you have any more questions regarding the GUI, please put it in the chat box and we will address it.
Uday Shankar, you're asking this question regarding the GUI or in general in OpenFOAM? Okay. So in OpenFOAM, you want to set up how to simulate a turbulent flow over airfoil using an ANS-based method. Okay. So in OpenFOAM, if you go in your tutorials where I'd shown you all in your OPT file, there are some tutorial files already available that use flow over an airfoil using the RANS model. So what you can do is copy those files and run them as it is to see how they've implemented all of that. Then accordingly, if you want to change any velocity or something, you can make those changes and you can go ahead with your simulation or any type of application that you want to go with. Okay.
Sir, how can we run this? Sir, I have a body like airfoil, sir. How can I apply polyhedra meshing or like polyhexacore meshing to that thing, sir? Like we do in Fluent with meshing, sir. How can we perform those activities in OpenFOAM, sir?
So you want to go for an unstructured mesh?
No, sir. I have to, sir. I mean, I want to go for a structured meshing, sir. How can I do that in OpenFOAM?
So you basically want to just mesh an airfoil, right? Flow over an airfoil.
Yes, sir.
Okay, so you can basically for the airfoil itself, there are two approaches to this. You can in block mesh use the spline utility to define your whole airfoil and then break your domain itself within different blocks. Or the second approach is you can use snappy hex mesh, in which you can specify basically you make a CAD file of your airfoil itself and you put it within that domain. And then using snappy hex mesh, you can make your 2D meshing file basically with Snappy Hex Mesh. You'll have that CAD file within it. So that way only.
Okay, sir. Thank you, sir.
Can I add a point here? Sorry, I'm Chandan. So basically, I just wanted to add the fact that if you have already used ANSYS and you know how to mesh it, ANSYS Fluent or any other sophisticated meshing tools such as Pointwise and other softwares, you can always import your mesh into OpenFOAM. That's basically one very useful um, feature of OpenFOAM, that OpenFOAM allows any third party meshing software exported mesh to be imported as polymesh within OpenFOAM. So apart from that, there are two other very powerful meshing tools which are open source available. One is called GMSH and another is Salome Mecha. So these are two meshing tools you can explore which are open source, and you can also make the mesh there and then import it into OpenFOAM. And there are different utilities, such as for GMSH, there is GMSH to foam. For ANSYS, Fluent Mesh to foam. These utilities can be used to import the mesh within OpenFOAM. Hope that is helpful. Thank you.
Yeah, thank you so much, Professor Chandan.